Hello there, fourth graders. Well, it's Labor Day weekend, and what else are you going to do on a Sunday but make math videos, right? Actually, if it wasn't 105 degrees out, no exaggeration there, I'd be out doing something. Anyway, I'm safe at home, not dying on the sidewalk. So, here we go. Today we're going to be subtracting larger numbers. This will be fun. You've done some subtraction already this year. At least you might have if you took on the problems I've posted up on the Do Now. But then again, maybe not, because I can't see your whiteboard and I don't know if you've taken a chance on these. Anyway, now you are going to get a chance to practice. First problem, I have 4,259 minus 2,171. Now, what you're going to notice first of all is there is probably going to have to be a little bit of what we call renaming. I'll show you what that means in a brief minute. But in the meantime, let's go ahead and square this away. The first thing we're going to do is we're going to say, okay, 9 subtract 1 is 8. Please remember that if you're subtracting, I know that some people have the tendency to, let's say, for example, in the very next place value, the 7 happens to be greater than the 5, and for some reason, kids this age still think they can switch those. You can't change the order of subtraction without changing your answer. It will give you actually the opposite of what you're looking for, and that would be wrong. Anyway, so I cannot subtract 7 tens from 5 tens. Therefore, I must go over to the hundreds place and do a little bit of borrowing. So I'm going to take from those, I'm going to take 100, which if you recall is the same as 10 tens, and I'm going to take those 10 tens and add those to the 5 tens that are already there. That makes 15 tens, and now I can subtract the 7 tens. There you go, 8 tens left. Now, the next place value, I've reduced my hundreds to 1 in the top number, and I have 1 to subtract in the bottom. There will be no need for renaming here. 1 minus 1 obviously is 0. And get on to the thousands place, and 4 minus 2 is 2. Now, just for the sake of discussion, I'm going to go ahead and draw this out on a place value chart. There's our top number. There is me subtracting 1 from that to get 8. And my regrouping maneuver, where I've taken the 200s and borrowed or renamed one of those hundreds as 10 tens and added those 10 tens to the 5 tens to make 15 tens. I'm doing this subtraction in my head. Those of you who like to do this stuff in your head, well, we do it all in our head, but don't like to write it down, there you go. Bonus experience for you. 100 minus 100, okay, that goes away, that's 0. And 4 minus 2 is obviously 2. Side note here, you must have enough value in the place to subtract. You may need to rename to do this. That's exactly what I've done. Like I've said now a couple times, you are going to have to take one of the hundreds from the 200 and rename it as 10 tens, because obviously 10 times 10 is 100. And now you've got 15 tens, perfect. Now I can subtract my 8 tens and be on my way. And just to emphasize the point, in case you decide to print this out as a PDF file, there it is. Now you try. What I want you to do is go ahead and take your whiteboard and put this, go ahead and copy the words down, not the words. How about the numbers? They work better. And copy the numbers down and then pause the video and go ahead and give me a solution. I know it's tempting not to do this just because, well, see, I've got things to do. Yeah, you've got math to do. I need you to practice first. Okay, you're going to pause here, and so will I. Okay, that was fun. Let's see what answer I get compare that to your answer. Well, I've got 4 minus 3 in the ones place, which leaves me with 1. 6 minus 1 equals 5. Come on, this is too easy, Mr. C. Oh, we have to rename here. We're going to have to borrow 1,000, which is the same as 10 hundreds. And now I have 13 hundreds, which is greater than 5. I needed to do that. And subtract the 5 from the 13 to leave 8. And then 7 minus 9, that won't work. I've got to go back over to the 10,000s place, borrow 1 10,000, which if I move that over, it becomes 10 1,000s, which is going to add to the 7 1,000s that are already there. That makes 17,000s. 17 minus 9 is 8. And then 1 minus 1, and I don't need to write the 0. I just leave it as is. Again, to restate, I needed to regroup twice. And by that, I mean rename, regroup. I kind of use those terms interchangeably, so don't get confused. I'm talking about the same thing. I moved over 100 and 1,000. So 2 borrowing operations, as we like to call them. And that goes back to the traditional algorithm developed many years ago, back when back before your parents were kids even. You know, when people rode horses to school. Kidding. Anyway, decomposing numbers when subtracting. Mr. C, we're not talking about dead things, are we? No, we're not. It's a term we use to talk about breaking down numbers when subtracting. I'm showing you this only because it's kind of a helpful guide if you're not seeing the algorithm. And the algorithm is a big word that we adults like to use to describe that method you saw for solving the subtraction problem. So here we go. I'm going to take the subtraction problem, 210,290 minus 45,720. Look at the numbers. Where do you need to decompose and regroup? Well, I notice I'm good to go on both the ones place and the tens place. Where the trouble begins is in the hundreds place. I'm going to have to do some decomposing. What makes this a little bit more complicated is I'm going to have to go all the way over to the 10,000s place to do my borrowing. In other words, to move part of that number over to the hundreds place. Let me show you what happens next. And this is called borrowing across zeros. And what I don't show you, well, first of all, what I did was I went ahead and borrowed and took the 10,000 and moved it over to the thousands place to make 10 1,000s. But my objective was to actually go all the way over to the hundreds place, which means I have to take one of those thousands, which is the same as 10 hundreds, and add those 10 hundreds to the 200s that are already there. That makes 12. 12 minus 7, well, actually, I'll do the subtraction next. What I like to do is I like to kind of complete the circle here. I'm going to go all the way over to the 100,000s place and fix up that, that 0 in the 10,000s place because I have to be able to subtract 4 10,000s. So that 100,000 is the same as 10 10,000s. I'm going to go ahead and regroup that so I can do the subtraction straight across. The reason I like to do it like this is because basically it's just all in one motion. I can subtract from left to right. I don't have to worry about anything else. I've done all my borrowing, all my regrouping, and now it's just a matter of simply subtracting the number on the bottom from the number on the top. So the first thing you might notice is that I made the other equation go away. Just like magic. Take that, Harry Potter. Anyway, so as I work through this problem then, I'm going to go back to the ones place. I know that 0 minus 0 is, well, last I checked, 0. And then 9 minus 2 is 7. And I'll put a stop here. Now you notice that I went ahead and did all my borrowing, all my regrouping, so I'm just going to go straight across. 12 minus 7 is going to be 5. I know there's going to be a comma there in front of the hundreds place. 9 minus 5 is 4. And 10 minus 4 is 6. And finally, 100,000 with nothing to subtract means I have 100,000. Now, what you've got here is just a really simple work through. The reason I showed you this, and you may not even get this until tomorrow in the problem set, is that you need to learn how to do the regrouping without getting hung up on, oh geez, what am I doing now? If you go back and re-listen to what I said, what you're going to notice are a couple things. First of all, when I regroup, I'm always borrowing from the next highest place value. So when I borrowed to make the 200s into 1200s, I had to take 1000s from the thousands place. Think about what I just said. 1000s, or 10 times 100, is equal to 1,000, right? That 10 is what I used to make the 200 bigger, right? I hope you get that. We can go back over this in class if you'd like. I can do example problems for you. But what I want you to understand is you've done this kind of stuff before. The only thing that's changed today is that the numbers are much larger. And by that, I mean they're probably a couple place values larger. All that means is it's kind of a rinse and repeat kind of a situation where you are going to be regrouping as you need to. You may be borrowing across zeros. If that becomes a problem for any of us, I'll go ahead and make a separate video just on borrowing across zeros. I have shown problems like that in the Do Now and haven't had any questions. I'm going to assume that there are some of you that are probably saying, okay, I don't need to ask that question because Mr. C didn't give me that for homework just yet. Well, now's the time to ask those questions. Anyway, I will be with you shortly. So good luck on starting the problem set, or actually the homework set. And